The title of this lesson is Interpreting Points on a Coordinate Plane. We have 3 learning targets today. First, I can explain what points in a 4-quadrant coordinate plane represent in a situation. I can plot points in the 4-quadrant coordinate plane to represent situations and solve problems. And 3, I can explain how rational numbers represent balances in a money context. So our first activity is just called unlabeled points. So as you can see, we have a 4-quadrant coordinate plane. And once again, just as a little refresher, remember, the normal coordinate plane that you've seen through most of your schooling is just here, this top right quadrant with just all positive numbers. And we call this quadrant 1. And then quadrant 2 is over here. So it actually kind of goes in this weird counterclockwise shape. 3 is down here. And then 4 is over here. And these are all the Roman numeral representations for the quadrants. So let's get started. So we have 4 quadrants, A, B, C, and D. And it is our job to find out which one of these points represents this ordered pair. So looking at A, we can see it's 7 and -5 and 5/10. So one thing that's really important to remember is that ordered pairs are always written in XY pairs. So X always comes first, as X does in the alphabet, and then Y. And so X, it kind of crosses over, right? And so it's kind of easy to remember. X is left and right, and Y, with that, how it has that little branch, that stick that goes up and down, and Y is the up and down axis. So if we look at A, it's 7, +7, so positive's always to the right, so 1, 2, 3, 4, 5, 6, 7, and then -5.5, so the Y coordinate is -5 and 5/10, and it's negative, so that's down 1, 2, 3, 4, 5, and then 5/10 is a half, so this is at -5.5, essentially. All right, B, -8, 4, so my X coordinate is -8, which is to the left. Negatives are to the left or down, so -1, 2, 3, 4, 5, 6, 7, 8. And then +4, so my Y is positive, so that's up, 1, 2, 3, 4. So there's B. You can see there, -8, +4, and they connect at B. C is +3 and 2, 1, 2, 3, over 3, up 2. And finally, D, that is -3 and 5/10. So back 1, 2, 3, and then a half, and then up 2/10. So you can see it's just a little bit off that line there. And there's D. Okay. On to the next page. So now here's where our lesson really begins, where we are using coordinate planes to talk about real-world contexts. So the graph shows the balance in the bank account over a period of 14 days. The axis labeled B represents the account balance in dollars, and the axis labeled D represents the day. So I'm actually going to add to this just to help me remember. So the x-axis, or the d-axis in this case, is the day, and this is the balance. Okay, which is how much money you have, essentially. A lot of times it's helpful to have those labeled. Okay, so estimate the greatest account balance. On which day did it occur? So once again, I can see over here the B-axis, which is actually like my Y-axis, is right here. So this is my money going up and down. You can see here, here's 0, right? The origin, that means you had no money, $50, $100. This shows up to 400. Then there's also negative dollars, right? Which means you're in debt. So you owe someone money. It is possible to have negative money. So let's look at the greatest account balance. So looking over, looks like this point right here is the highest. And so what does that balance look like? Well, so it's in between 350 and 400. It looks like it's right in between those, like right in the middle. So we're going to say it's about $375. And this is on what day? So remember, my x-axis, or in this case we're calling it the d-axis, this is my days, and this is on day 14. Estimate the least account balance, and on which day did it occur. So, what is the lowest point? That would happen to be right here. And that looks, it's in between -50 and -100. It's a little bit closer to the 100, so let's say that's -$80. And that happened on day 11. So what does the point 6, -50 tell us about your account balance? So 6 tells us about the day. So on the 6th day, and the Y is the balance. On the 6th day, they had -$50, which meant they owed $50. All right. And so how can we interpret the absolute value of -50 in the context? And so once again, so absolute value is a number's distance from 0. So we can write that. And -50 is 50. The absolute value of -50 is 50 because it's 50 dollars away from 0, and that is how much money you'd have to spend to get out of debt. Which is $50, right? So it's basically saying, if you had -$50, how much money would you have to pay before you got back to a 0 balance? $50. All right, on to the next one. So we've got another coordinate plane here with the positives and negatives. This time we are talking about high and low temperatures. So the coordinate plane shows the high and low temperatures in Nome, Alaska over a period of 8 days. The axis labeled T represents the temperature, and the axis labeled D represents the day. So here's D, once again, day, and temperature. Just so we remember, we don't get those mixed up. So, and you can see for each of these, right, it shows the high and low temperature. So you can see that on each day, there are 2 points. The red is the high and the blue is the low, right? Because whenever we talk about temperature, if you look at the Weather Channel or whatever, every day has a high and low temperature. So that's why for each day, red is the high, blue is the low. And so what was the warmest high temperature? So if it's high, we're talking about the red. And the warmest temperature that we can see is right here, and that would be 28 degrees. Fahrenheit. We're talking about Fahrenheit this time. All right. Rate an inequality to describe the high temperatures, H, over the 8-day period. And it says in parentheses, the highest temperature was always warmer than what? So, I'm looking at all the highs, all the reds, and I have one here. And that was 2. Okay, 2 degrees. So, the high temperature was always greater than 2 or equal to 2. Okay? It was the high temperature was always 2 or more. And if we wanted to go the other way, here's the highest temperature, so this is the maximum, so the high was always less than 28 or equal to 28. And remember, we can also represent each of these instead of doing the 2 inequalities. This is what you're going to have to do on your computer. Later we'll be working with this symbol, which is greater than or equal to, or less than or equal to. And what this tells us is that the high temperature was always between 2 and 28 degrees. this is the maximum temperature it could be, this is the minimum. Now write an inequality to describe the low temperatures over the 8-day period. So here is the highest low temperature. The highest blue is 26. So H was always less than or equal to 26. And here's the lowest, which is, looks like -3 about. And H was always greater than or equal to -3 degrees. So once again, this shows a range, okay? And I shouldn't have used H here, that's my bad. Because we're talking about the low temperatures, it says to use L. So I should have used L, not H. Alright, on which days did the largest difference between the high and low temperatures occur? So, on what days is there the largest difference between the highs and lows? So right here, I can see that these were really close together on this day. The high and low, the high's 28, the low's 26, so there's a 2-degree difference. Here, 26 and 20, so a 6-degree difference. Here, this one looks a little bit bigger. We're at 21 and 11, so this one's got a 10-degree difference. So that one's pretty big. This is 11 and 3, so 8 degrees. This one looks kind of big as well. That's 17 and 7. So that one also looks to be about 10 degrees. So on days 3 and 6, they had a difference of 10 degrees. So once again, if we look at Y, because 21 minus 11 equals 10, and then on day 6 we had 17 and 7. So they were 10 degrees apart on that day. And which days was there the smallest difference? It looks like this one is where they are the closest apart, the smallest difference. So on day 1, the differences were really small. It was just 2 degrees. And once again, that's because we did 28 minus 26, and that's 2 degrees. So, smallest difference, remember, difference is answer to a subtraction problem is one definition. It's also how far apart two values are. All right. There's that. And now, just for our big ideas, so make sure that you go over and read the lesson summary. Essentially, we were talking about how coordinate planes tell us about a context or situation. The big ideas you should type. So we use graphs to represent relationships in real-world situations. And each axis represents a different quantity, and we can use the points to make conclusions about them. All right. So once again, we were looking at these graphs of temperature and money, and we were looking at the points, and we could make statements that on such and such day, they had this much money, or on such and such day, it was this temperature, and so on.